So we've got a rate of question here relating to water in a bowl. So you've got a bowl as pictured down below. The volume of the water in the bowl based on the height h as drawn here is given by v equals 1/3 pi h squared 30 minus h. When they give you a formula like that, you don't need to prove it, you can just take it. Water is being poured into the bowl at a rate of 2 cubic centimeters per second. So when you're reading these questions, you should always make sure that you're getting a sense of what's going on. So if V is the volume of water and you're pouring more water in, that means V is going up. And this rate of 2 cubic meters per second is really then telling you that the rate of the water going up, in other words, dV dt, because it's going up, it's positive, and it's 2 cubic centimeters per second. That's basically what they're saying. And that will hopefully be helpful later in the question. And it's basically a good idea to basically take a look at the question and get the information you can out of it when you're reading it for the first time. Now we know the radius is 10. Okay, and it gets the depth of h. Now, if the radius of the water, we've got a few questions, is r centimeters, okay, then show that r is that. Then later on, you want to find the rate of change of the water level and the rate of change of the radius of the water surface. Great. So we want to show r equals the square root of 20h minus h squared. And it's actually not too difficult as long as you know sort of where to look for this. So imagine that's a circle and you have your water circle over here. And the ones that relate to the measurements of the water are in letters R and H. But the ones that relate to the bowl are fixed because after all, the bowl's not changing in size. So that's 10 centimeters. Now, because you want to find R in terms of H, what might be most helpful is basically to look at this cross section here. Okay, so now that we've got cross section there, we recognize that this is 10 centimeters. We recognize you've got water like so. Imagine that's flat and imagine that's a circle. And you can think of this sort of cutout down here as before. We know that this here is H. We know that this here is R. But what might be most helpful to look at when you look at these sort of questions is you want to link the 10 centimeters into your R. And often similar triangles might be a way to go, although that's going to be less common in current papers. But you don't have a similar triangle because you've got a curve, not a straight line. If it's a straight line, you might consider similar triangles. But when it's a curve, in particular circle, you should consider drawing this line in red. And the reason why that line might be helpful is think of what that line is, right? This is a circle, should be anyway. This is 10 centimeters. And so if this is a circle, this is really, the red line is really the radius of the circle, which we know from above is 10 centimeters. So we now have a relationship between 10, a number, and R, and that relationship can be found in this right angle triangle. So this right angle triangle, where the vertical one is yellow, the hypotenuse here is red, and the horizontal one is part of the blue line. Well, let's just deconstruct it. This is R, this is 10. And over here, this length, well, very similarly, this yellow line that I've drawn down is also a radius of a circle. This is still also the radius of the circle. which means the entire length of that is 10. But if that's 10 and this is h, then of course, this length here is going to be 10 minus h. And now that we've got a right angle triangle, we can then use Pythagoras' theorem. 10 squared equals 10 minus h all squared plus r squared. Which of course means r squared must equal 10 squared minus 10 minus h all squared. And therefore, r must equal the square root of 20h minus h squared. And that's it. That's how you do part 1. Now, part 2 says when the depth of the water is 4 centimeters. So when the depth is 4 centimeters, find in terms of theta 2 the rate of change of the water level and part 3, the rate of change of the radius of the water surface. Now, when you're looking at this, you should be reading the questions and making sure you understand what this is saying. See, when the depth of the water is 4 centimeters, that's really saying h equals 4. You want to find the rate of change. The rate of change is really saying d something, d something. Well, what are we trying to find the change for of the water level? Well, the change of the water level will be represented by, I guess, the depth of the water level, right? So we're really trying to find the rate of change of h. But I guess why is it changing? Well, I guess it's changing because you're pouring more water in. As the question said, you're pouring water in. So as you pour water in, remember earlier we had identified that dV dt, the volume of the water was being poured in, was going to be positive 2 cubic centimeters per second. So in other words, we're pouring water in. So it's really a change with respect to time. As time goes on, you're pouring more water in, which of course means the height of the water will increase, which means we expect this to be positive. I mean, we don't know what the answer is yet, but we expect this to be positive. And then the rate of change of the radius, well, again, it's a rate of change. So that's d something of the radius this time, dr dt, because we've said before, of the water surface. Okay, so that's what we want to find when h is 4. So in other words, the question can be written as find dh dt when h is 4, find dr dt when h is 4. Okay, so we're going to rely on formulas that we already have. The volume is 1/3 pi h squared 30 minus h. That's given in the question. Well, let's derive it with respect to h. In fact, before we do that, let's just rewrite it in perhaps a nicer, more convenient form. That's the same thing. So we can now derive that quite easily. So that's dV dh. Now, we're not interested in dV dh specifically, we're interested in dH dt. So for part 2, we want to find dH dt. And we need to use the chain rule. dH dt must be, well, we just need something in between to kind of get us there. And the only thing we have right now is dV. So dH dt is dH dV times dV dt. And then think of it like fractions. I know they're not technically fractions, but the dV's kind of cancel. And so we've got dH dt. So that then means that will give us what we want. So dH dV is just going to be the reciprocal of that. So if you think of this as a fraction, then dH dV will be the reciprocal. And dV dt we just know is 2. So we now have dHdt for all h. But the question is asking us to find for h equals 4. So we sub h equals 4. And we're going to get 6 over pi. Okay, so we're going to get 1 over 32 pi. Now, usually they won't be too picky, but you also should be paying attention to units because all your units are in centimeters here. That will be centimeters per second. This is in centimeters, that's in seconds. So the height is in centimeters, and you can confirm that in this case. They are measured in centimeters. So that will be that specific dHdt at that point. We'll do something very similar then. We can either redo the entire question in terms of dr dt, and that can be done, but it probably won't be so necessary. So we now need to find the rate of change of r. Now, we also know that r equals the square root of 20h minus h squared. And we're basically asked to find dr dt when h equals 4. Well, there's a few different ways we could do this. But ultimately, since r is in terms of h, we need to derive r. So dr dh is, let's just do this on a new page so we have a bit more space. The question is to find dr dt when h equals 4. Well, we know r must equal the square root of 20h minus h squared. So firstly, we'll need to find dr dh. So if it helps, you can think of this as 20h minus h squared to the power of a half. So you bring the half down, 20h minus h squared to the negative a half. And then, of course, chain rule. So 20 minus 2h. So times by half, that means you've got 10 minus h in the numerator divided by the square root of 20h minus h squared. So that's your dr dh. Now you want to find dr dt, which means it's going to be dr on the top, dt in the numerator. And right now, the only link you have directly linking to it is dh. So you've got dr dh times dh dt. Well, dr dh you've already worked out from above. dh dt you can write in this sort of expression over here, 6 over that if you like. I mean, it's not really necessary, but we'll just write it in for now. We'll keep it general. And then basically we need to sub h equals 4. Now, let's not bother doing the same work again here on the right. We know the answer to that. We did that earlier. That's just 1 over 32 pi on the right-hand side, because we literally did that earlier, right? It's 1 over 32 pi. So what we now want is to sub 4 in there. So 10 minus 4 is 6. And then you're going to get the square root of 80 minus 16, which is 64. So it's going to be that. And then this will give you then an answer of, well, 3 over 128 pi centimeters per second. So therefore, the RDT equals positive 3 over 128 pi centimeters per second when h equals 4. And that would be your answer to part 3. And that's how you do it.